Oh, thank you, Joaquin. Yeah, I'm going to talk about IPSO smart objects and what they are, what we've done so far, and what we want to do in the future, what we're going to do going forward. So basically, IP for Smart Objects is an alliance of several companies. You can go to the website and find out who's in, but there are a lot of people in there. And we have the Smart Object Committee, wherein we define smart objects. And the overall goal is for semantic interoperability between devices and sensors and actuators and the applications that control them, to have a standard set of semantics that can be used to sort of provide plug-and-play interoperability between both devices and applications. Right, and we are using the lightweight M2M object model pretty much as it is, but we're exploiting the concept of reusable IDs for the objects and the resources. So when you create a temperature object, that is intended to be reusable anytime you need a temperature measurement. Unless you need something very, very special, the one temperature object should serve that purpose, right? And they're also meant to be usable across different transport protocols. So CoAP for sure with lightweight M2M, but also if you have a proxy for HTTP or a MQTT transport layer, you can send the object ID and data over. As long as you can support the data types, content formats, and the basic operations, you can interface with lightweight M2M and IPSO objects. So we have a basic starter pack that we call, a set of simple objects that we published last year for some simple sensors and actuators. And we've got some extensions in progress to broaden out the use cases that IPSO objects can apply to. The basic idea, as you've heard several times today, is web-to-the-edge pattern. So what we have is all of this IP-based technology for the lower part of the stack, CoAP and OMA lightweight M2M, and then IPSO objects are meant to be a layer, a semantic layer that applications can use. And this is the object template. You've probably seen some of these, but I'll break it down a little bit more. The first number is the object ID, and that defines the type of object that it is, temperature, pressure, humidity, what have you. The second is object instance, because you can have more than one instance. You can have up to 65,335 instances of any given object type at an endpoint. And the third number is the resource ID, and you can have, again, 65,000 plus different kinds of resources. And those are all resources, reusable resources, so one resource out of one object could be used, the same ID is used in other objects. So it's different from the way the management objects are structured, where the resources start at 0 in each object. These are reusable resources. And I already talked about the protocols, so I'll go on. Here's an example of an IPSO smart object. This is the temperature object, and I think Antonio already showed, sort of what the basic thing is. We have the sensor value. The newer, latest spec, we're allowing engineering units to be a resource, so you can have a temperature sensor that exposes Celsius, one that exposes Fahrenheit, and even possibly one that the application can write this resource and change the representation units that the sensor is delivering. Minimum and maximum measured value, minimum and maximum range, and a resource to go and reset the min and max. So if you want to find the min and max over a certain period, you go reset it, wait for that period, go read, and then you can find what the min and max was. And all of the basic sensors have these same set of resources in them. And this is the starter pack, the Smart Object Starter Pack. Just a list of the objects. I won't read them out to you. You can go look at them on the slide, but they're the basic things. There wasn't a loudness sensor or a sound sensor, but we could add that, for example. And so one of the things we need to do is just figure out what are the basic sensors that we need to add to fill out this list to have a more broadly applicable set. They're very easy to add. Not going to take much to do that. So also we're looking at things like, well, what if you have something existing you want to express in IPSO objects? So the BLE heart rate sensor maps almost one-to-one. You can just have a simple thin layer of software that reads the characteristics and creates the objects. And I do this on a toolkit that I have on Python. You can also define, more complex objects if you want. And this is like, I took the Nest Thermostat API JSON that they publish and cast it as an IPSO object. So, you can do it, but you have to create a lot of sort of special resources, and it's kind of ad hoc. So there might be a better way to do that, but nonetheless, if you had something you needed to do ad hoc, you could do it this way. Okay, so that's pretty much where smart objects are now. We define the basic set and just some basic parameters. What we want to do in the roadmap, this is sort of a laundry list, if you will. Not all of these things are actually committed or have people to work on them, but this is a set of things that kind of represent the future for IPSO smart objects. We want to cover more use cases, but we need people to join the committee and drive that and own those. We need some experts in the domains to come and kind of help with their experience on how these objects should look to be the right kind of interfaces for that domain. We need more basic objects just to fill out that set. And there are things that people want to do with IPSO objects, like build models for home appliances, like a washing machine model or a refrigerator model. And those are going to require some extensions to what we're doing to make that really, really easy to do. So kind of what we're looking at is building complex composite objects using the object linking, which is a new feature in lightweight M2M that just being proposed. So the idea is to take a set of basic objects and compose a complex object out of those, for the most part. Also, we're looking at connecting to a lot of existing stuff out there. So people want to interwork with TR69, for example, Zigbee stuff and Bluetooth. We want to look at how we harmonize those object models. How can we eventually have a future where there's just a single set of object models? Bluetooth and Zigbee are sort of out there now, and they've done some useful stuff, but how can we go harmonize that in the future? We need to produce a standalone schema and maybe some templates so that there's a reference for how objects should be constructed, and also how clients could use them and how servers could use them. And as mentioned, we want to look at enabling device-to-device interaction, reusing as much as we can from lightweight M2M to enable IPSO objects in a sort of peer-to-peer, application peer sort of scenario. Now, so this is sort of what a composite smart object might look like, just a sort of a sketch. You might have some actuators, you might have some special objects, you might have some IOs, and sort of that makes a module. And that's basically like a model of a high-level appliance or something like that. There's more to it than that, but that's the concept that we want to implement. So object linking is basically how we would do that. We want to use object link to compose objects. And basically, it's a new data type that's 32-bit binary that represents an object and its instance. So from one object, you can create a resource that points to another instance of another object in your endpoint. And then having enough links, you can compose them. It's just more like the web, whereas with JSONs, they tend to nest them sort of arbitrarily deep. What we want to do is have one level plus linking so that you can go object, resource, object, and then you can nest by linking. But the client is a lot easier because it can use like a web link follower. You read the link, you follow it, and oh, there's another link, I follow that. You don't have to have a lot of recursion that way. And the linked objects can be serialized bulk using SendML. So if you do a read and ask for SendML, you'll get all of the objects, all the resources, and in line where they're linked. So it'll look like a nested object, but it's actually linked. And here's an example of how that would sort of look. I chose a thermostat example. So you'd have, in a thermostat, you have a temperature sensor. You measure temperature, you have a set point, how warm do I want the room, and then you have an actuation, turn the heater on and off, or the air conditioner. And so here's an IPSO object that would do that. The way we see that working now as sort of a straw man is the links could be typed. So you could have an object, or yeah, an object ID that represents the input link, and it links to a temperature. But you could also say, here's an input link. My controller, I'm going to control humidity. So you could substitute humidity for that. And you could call it a humidistat controller, for example, and maybe reuse the same basic pattern. Link to a set point, it might come from a dial on a box on the wall, or it might come from someone plugging in a number on their smartphone or moving a slider on some GUI. And then the output link, again, can go control the heater, or it can control a dehumidifier or some other device. So here's a sort of a reusable pattern that can be used to make almost any kind of controller device. Not clear whether we would have an ID for thermostat and an ID for humidistat and an ID for a pressure controller, flow controller. We might have one ID for controller and then use application type to determine what it's actually controlling. And that's kind of an open question. We kind of need people to come into the committee and help us figure out which way we should go on a lot of these sort of semantic questions and issues. The next thing is sort of the idea of application templates. There isn't really a single place where an application developer can express all of the constructor parameters and write attributes and all of that that you can do set on objects and resources. So the idea, and a lot of other people are working on similar things, is create a schema for templates that can be used to statically declare all these things, and then can be used as constructors, descriptors, hypermedia controls, and this kind of thing in APIs. So it's one way you could actually construct linked objects and composite objects by using a template. There has to be some way to say how this is going to get built. You can use it to set observe attributes and settings. Right now, it's sort of, your application has to just code that and go in and code query parameters, but we could have a declarative template for that. We could add core link format descriptors. So if you wanted to add more semantic description to what you register as the link bundle when you register, you could add things like units, engineering units, and things like that, resource type. Even though they're in as resources, they could also be added as semantic descriptors to enable a different kind of discovery by doing discover instead of by doing read. Semantic hooks for abstract models. There are some high-level model builder things that are used to sort of create other objects. And if we could add information to objects to guide those builders, that's a possible use of templates as well. And then I mentioned hypermedia templates already. And this could be layered. So you could have one JSON for the basic thing and another JSON that would layer on top of it, et cetera, assuming you use JSON. And I think the DDF file would still be the definitive root description for these things. Right? So here's an example of how you would build a composite object by linking a number of objects together. It's a JSON template that expresses the thing I showed, the thermostat linking to 3 other objects. I just made this up, so obviously there are a lot of different ways this could be constructed, but this is sort of what the idea is. And also for semantic annotation and for settings and things like that, this is sort of a sparse template. Obviously you could fill it out and have everything on every level, but sort of the idea is you describe your objects, instances, and resources by objects in a JSON by nested objects, and then you specify in those objects what you want to do. And this is sort of, you have a schema. The idea here is that sort of you can define individual instances of things and then communicate that as a hypermedia control as well. So, I already said that. So the last thing I want to talk about was sort of this idea of peer-to-peer and how lightweight M2M servers might be used. So I made a sketch of the whole use case, and the idea is that you can have services, and you can have more than one service in the center that sensors and devices register with, typical lightweight M2M, and then applications can interact with through the server, and that's the typical proxy pattern. But we also need, in many use cases, for devices with embedded applications to be able to interact directly with other devices. So that's where this the other part of this model comes in. We want to enable both the peer-to-peer interactions as well as managed interactions. as well as to enable the embedded app devices to be able to use the lightweight M2M server to register things and to discover things. And a little bit more about that. One example is the connected home. You've got a bunch of different devices, different capabilities on different networks. They're probably all IP networks, except for maybe some, like BTLE here. Well, that'll be IP very soon too. Maybe I should use Zigbee as another example, but this is the scenario. There are maybe 3 different management scenarios. You can manage from a cloud service devices. You can manage from a local application server or application hub type device, or you can directly manage from a device that's running an app. And in the case of a wearable, you don't really need all the cloud service connection from the management. You just sort of set it up with your cell phone. The same with the interactions. You can have interactions, direct interactions of binding and pairing between a light switch or a door lock and something like that. You can have local application controls like for home entertainment scenes and things like that. And then cloud services to do things like energy management, and your electricity company can monitor your usage and give you a better rate, for example. So those scenarios all need to be accommodated in these use cases. And also the idea of application devices that run applications then can just directly interact with other devices that they can control. So that's partly facilitated by the co-app pattern of local discovery using multicast or broadcast. Obviously, you could also use a lightweight M2M server to do discovery through. We want to look at providing both methods. And lastly, I wanted to just show the idea of interacting with devices through the lightweight M2M server. Devices can register, and then applications can discover by doing the discover and read operations. There's a standard reverse proxy. An application does a GET. The GET goes to the device. The reply comes back from the device and goes back to the application. This can translate between, say, CoAP and HTTP, and by using the same object format, the application doesn't really need to know what kind of transport layer is being used. It makes it really easy to just make an automatic connector. Asynchronous notifications go back some way. Of course, HTTP, you'd have to figure out how you're going to do that. But basically, that proxy could be used. So your application could only needs to ever interact with the lightweight M2M server. I believe that's all I have. Oh, yeah. And the other thing is it's really handy. I use this all the time to keep a tunnel open on NAT. Just do regular registration updates. Now, UDP likes to time out after 60 seconds, so I just set it at 30 seconds. Sends a 30-byte packet, an empty packet, just headers and no payload, and keeps the tunnel open. So then the server layer can go through the NAT and do gets and updates and things like that, writes and reads.